Welcome to my channel. In this video, we are going to discuss pulse amplitude modulation and demodulation experiment. And Mr. Ankit and Prajwal has done the experiment, and all the CRO snapshot they have provided me, and they helped me to prepare this particular videos. Pulse amplitude modulation is an analog modulating scheme in which the amplitude of the pulse carries a variance proportional to the instantaneous amplitude of the message signal. So in general, you remember, all of you, modulation means change. Amplitude modulation means I am changing the amplitude. Frequency modulation means I am changing the frequency. PAM means I am changing the pulse amplitude. Modulation means I am changing. In brief, you can remember for any modulation technique. The pulse amplitude modulated signal will follow the amplitude of the original signal as a signal traces out the path of the whole wave. In natural PAM, the signal sampled at an increased rate is reconstructed by passing through the low pass filter. The circuit will be shown to you people. This is M of t, input I am applying. This is a carrier signal. This is a pulse amplitude modulated signal. You can observe on the CRO. And this reconstructed. Amplitude will be less, but the same waveform you are going to get. Required components: we need a transistor, resistor, capacitor, a function generator, and CRO. One should know a transistor as a switch to understand this experiment. If the transistor is operated in the saturation region, then it acts as a closed switch. When it is operated in the cutoff region, then it behaves as an open switch. One should know the transistor as a switch. It's very simple to understand. With zero signal applied to the base, emitter and collectors will be off or open circuited. When you apply something to the base, automatically this emitter to collector will be short circuited. You can pause the video and try to understand by reading these two lines. This is a PAM circuit diagram. Just now I told we are going to use a transistor as a switch. When you are positive you are applying, that time it will be short circuited, and other time it will be open circuited. Therefore, only at a particular time output and input will be same. The demodulator circuit is very simple. It's basically a low pass filter. And you have to choose a carrier. This FC says that you should allow the modulating signal and you should not allow the carrier. Procedure is as follows. Connections are made as per the circuit diagram, and turn on the power supply, adjust the amplitude of the frequency of the modulating as well as carrier signal so that you can get a PM output. Make sure that the frequency of the carrier is much greater than the FM, or you can say a message signal, so that you can observe the output properly. Vary the frequency and amplitude and observe the PM signal. Once if you get output, apply the generated PM waveform to the demodulation circuit. Adjust the capacitance to reduce the ripples so that you can get a proper demodulated output, and note down the waveforms. Experiment setup is shown. It is a complete setup. It is a top view of the circuit using a springboard, and observation message signal is observed on the CRO, then carrier signal, and it is a PAM, pulse amplitude modulated, and all the three have been shown. CRO screenshots, and FC is 3.5 kilohertz, and this is a PAM. Observe that this should be less than 3.5. How many you want? Number of samples, based on that you can select a carrier. And different carrier frequency, when you change it, when you increase it, you observe the PM. Reduce it, observe the PM. Understand why it's happening like this, because transistor is open for longer time and closed for longer time. And pulse amplitude, when you give it to the demodulator, this is the output waveform what you are observing. By varying the RC value, you can get the little proper output waveform. Even you can use a better filters also. Applications are many. To name a few, it is listed. Pause the video, go through. To control the signals in the microcontroller, graphics card for a high-speed networking and reduce the noise to signal ratio. Some applications are listed, and try to go through these applications, and you can browse for further information. The reference is Ramakanth Gaikwad, Op-Amp and Linear Integrated Circuit. For more information, you can visit these links. And thanks for visiting this video. Share this video if you like with your classmates. Subscribe this channel. Thank you.